Hopefully this will be the last recording. I've done it. This is my third time. Really? All right. Hey, I chewed out a couple of boys first period, and that was on tape. So that does happen. Okay, so here we go. Geometric sequences. We worked with arithmetic sequences before. Today it's the same ideas, only working with geometric sequences only. So geometric sequences have a common ratio. What do I multiply to get the next term? Never want to think about it as division. You only want to think about it as multiplication. So if it's going down by 1/3, if you're dividing by 3, that's the same as multiplying by 1/3. You have to have that in there. That what do I multiply by? Geometric means missing teams between two other numbers. We're going to do the same thing we did with the arithmetic means, only a different process, but still the same idea, filling in the blanks between numbers. And then we have our new formula, and I have it over there. I'm going to rewrite it up here. A sub n equals a sub 1 r to the n minus 1 power. Okay, we know what a sub n stands for. It's the nth term. A sub 1 is the first term. N is term number. R is our ratio. So this formula, as you can see, is different than the formula we got before. Most of the terms are the same. Difference for arithmetic, ratio for geometric, and rearrange. The important thing you've got to watch for, the thing that screws up a lot of people, the n minus 1. And remember, the other thing is, what do I do first? Exponents before the multiplication. And like I said, you will need your calculators to do this today. You cannot do this. Okay, you can do it by hand. You sure don't want to do it by hand. Most of it. Okay? Questions? Okay. So here we go. So the first example is determine if the following are geometric, yes or no. If so, find R. Now, some patterns, it's very easy to see right away whether geometric or arithmetic, how to find one from the other. The first one is not. Okay, I can tell easily it's not arithmetic because I'm not, 3 plus 6 is 9, 9 plus 3 is not 13.5. So I know it's not arithmetic, but it's not necessarily easy to see that it's geometric. How can I tell for sure? Take a number, divide it by the previous one. 9 divided by 6. Okay, that ends up being 3/2 or 1.5. Normally, decimals are not allowed. However, that sequence contains decimals, so decimals are fine because it already contains decimals. This is not enough to know if it's geometric or not. I have to check other terms. Do the same thing, 13.5 divided by 9, and you do get 1.5. And if you take 20.25 divided by 13.5, once again, you do get 1.5. So it is geometric, and R is not 1.15, is 1.5. Okay. Next one, same idea. How do I get from one to the next? Now, I like it when there are whole numbers and fractions right next to each other because that generally makes it easy to figure out what's going on. I go from 3 to 3/4. If I multiply 3 by 1/4, that gives me 3/4 because 3 over 1 times 1 over 4 gives me 3/4. So if I take 12 times 1/4, if I take 1/4 of 12, I get 3. So it is. And if I multiply 3 over 4 times 1 over 4, I get 3/16. So this one is geometric, and R is 1/4. Once again, if you need to, just divide by the previous one. But you do want to keep them as fractions, not decimals. Okay. What about this one here? -5/5, -5/5, -5/5, -5/5. What am I doing? It's -1. I'm multiplying by -1 every time. This is geometric. R is -1. And then the last example. This is a recursive formula. Now, with the arithmetic recursive formulas, what did you do? It was a sub n minus 1 plus or minus something, only plus or minus. That was a recursive formula for arithmetic. So if I'm adding, it's arithmetic. How do I get to the next term? That's what the recursive one does. I start with 2. How do I get the next term? I multiply by -3. How do I get the next term? I multiply by -3. How do I get to the next term? I multiply by -3. How do I get the next term? I take the one before it times -3. That's what this tells me. So if I'm multiplying by -3 each time, it is geometric and its r is -3. Because that's all I'm doing to get the next term is I'm multiplying times -3. And that's the definition of a geometric sequence, multiplying by the same number to get the next one each time. Okay? Your turn. Do those. Okay, here we go. Let's do these. So the first one. It is not geometric. I'm actually subtracting 5 each time, which means it's arithmetic, but it is not geometric. Second one, you want to check it. It doesn't look like it is, or you're not sure. It's definitely not arithmetic. What do? You divide, and yes, it is geometric, and r is 0.4. Okay. Third one, yes or no? No, because although I am multiplying every time, I am also adding. I can't do both and have it be geometric. This one is not. And then the last one, it is not because I'm just subtracting each time. I'm not multiplying. Geometric is you multiply every time. This one is actually arithmetic, but it is not geometric. So, I thought you probably figured at least half of them were and half of them weren't, right? That's your guess, and you get to the last one and say, oh, it's got to be because, no. Wahahaha. Okay. Now the fun begins. We get to use our new formula. So we have, once again, 4 things: the nth term, the first term, the ratio, and n, the number of terms we have. Got to fill it in. We're looking for the 9th term, which means that n equals 9. A sub 1 is the first term. And then you have to figure out what r is. Okay? What do I multiply 3/8 by to get -3/4? The easy way, or a way to do it for sure. Do that. Your calculator will do this as a fraction and give you a fractional answer if that's what it should be. -3/4 divided by 3/8. And you get -2. So r is -2. Plug them in. The ninth term is 3/8 times -2 to the 9 minus 1 power. When you're doing this on your calculator, do it very carefully. Make sure the power you're putting in is the correct number. There is a huge difference between 9 minus 1 and 9. You have to be careful how you're putting these in. What do I do first? Multiply by 3/8 or do the exponent? Do the exponent first. Make sure you're doing it correctly. Okay. And if you do it correctly, you should get 96. And you do it correctly, you end up getting 96. To the 9 minus 1. Sorry, my lowercase a's and my 9's look very similar. do this again on the next one. Once again, n equals 10. A sub 1 is 5. What's my r? How do I get from 5 to 5/3, from 5/3 to 5/9? But I can't do it division by 3. I need to make it multiplication by 1/3. Remember, it's always multiplication. Your r is always what you're multiplying by. Okay. So I have a sub 10 is equal to 5 times 1/3 to the 10 minus 1 power. Try doing that on your calculator. See if it will give you the fraction that you should have, because it has a fraction in it. A decimal answer will not be correct. If this was a test question, I would require a fractional answer for it. Okay. Okay, on your calculator, you should have a fraction key that looks like A over B or A, B over C. Looks like a fraction. Type in the numerator, hit that key. Type in the denominator, hit that key. Okay. So you should get 5 over 1,968, 19,683. Okay, now, some calculators, it's my understanding, are having issues. And it's giving you some big fat decimal instead. Here's what you need to understand. If I am taking 1/3 to the 9th power, because that's what I'm doing, right? 1/3 to the 9th power, and then multiplying that times 5, right? Okay, well, this is 1 to the 9th over 3 to the 9th. And 1 to the 9th is 1, and 3 to the 9th you can do on your calculator to figure out what the denominator is all on its own without having to do it as part of the fraction. Take 3 to the 9th power on your calculator, and you will get 19,683. Which I know is not my answer, but what do I have to do? I have to multiply it by the 5, so the 1 becomes the 5. You can do a fraction on your calculator. If your calculator will not handle the fraction that big without giving you a decimal, just do the numerator as 1 and do the denominator as the other. Write them down separately. And that's perfectly acceptable. But if you give me a decimal instead of the fraction, you will get marked wrong. Okay? Start out as fractions and need fractions. And I do believe the directions on the test say leave answers as fractions. I do believe it says that specifically on the test. So you've got to figure out how to either make sure your calculator does them as a fraction or how to do it like this. Okay? Okay. So once again, we're looking, the nth term is n is 8. A sub 1 is 4. R in this case is -3. Okay. So the 8th term, a sub 8, is 4 times -3 to the 8 minus 1 power. Be careful, particularly when you're raising a negative number. When you have r is negative, you've got to be careful about what your answers are going to be. If you type it in wrong, you're going to get it wrong.
How do you type it in so fast?
Put parentheses around the -3.
You put in the whole equation.
I can type it in just like that. 4, exactly like it is here. Only I go ahead and subtract the I subtract the 7 from the 1 from the 8, or the 1 from the 8 to get 7.
How do you put the 7 in?
You should have to type it in your calculator. 4, -3. Should have like a little caret key or something like that, and that's your power. And then I did 7, and you get -8748. Okay. So, and if you put in the wrong exponent, or don't put in the negative right, that could be a problem. Because if it was an even exponent, it should have come out positive. The next number is going to be positive. So if I was looking for the ninth term, it would have been a positive. And if you typed in wrong and you gave me negative, you got to watch that. That's a very common mistake. And then on the next one, a sub 1 is negative 2 over 27. N is 11. R in this case is 3. Okay? R is 3 in this case. So a sub 11, negative 2 over 27 times 3 to the 11 minus 1 power.
Is it always minus 1?
Always. And you end up getting negative 4374. Yes, the first one was negative 87874. Okay, hang on. Okay. So the next one, very nasty. I can show you how to solve it.
We'll save it for next week.
Very nasty.
Yeah, let's save that.
And those are the examples of the very nasties, which we will come back to after we do this, because there's an easy way to do those, a very easy way to do those, but we need to come to here first. So what we're going to do is, we did the geometric mean thing before for the arithmetic. Concept is still the same. I have 5 and then 3 missing terms between 5 and 80. And I need to find those missing terms. Now what we did with the arithmetic means is we found D and then added D each time. For the geometric means, we're going to find R. Now with the arithmetic ones, what did we do? We took the last one, subtracted the one in front. For geometric, we don't subtract, we divide. So I take the last number divided by the first number. Now with the arithmetic means, what else did we do then? Then we divided that number by how many spaces plus 1. Okay, once again, this is geometric. Instead of doing that, we are going to take the root, and in this case the fourth root, because there are 3 spaces plus 1. So you're doing the fourth root of 80 divided by 5. Okay, now you can do this on your calculator. If you type it in just like it is here, your calculator will spit out the right answer. You can also take a minute and go, okay, that's the fourth root of 16. 80 divided by 5 is 16, and the fourth root of 16 is 2.
How do you do root on here?
Okay. To return. So we figured out R is 2. So here's what I do. I do 2 times every number here. 2 times 5 is 10, times 2 is 20, times 2 is 40, and I always do it one more time. 40 times 2 is 80. I got it right. Do it one more time to check your answer. Okay? Now, come on, there we go. Next one, same idea. Okay? 3 geometric terms between 64 and 4. 64, 1, 2, 3, 4. Filling in the blanks. Need to find R. Same idea. Take the last one, divide it by the previous one. 4 over 64. And then I want to take a root, and I want to take the 1, 2, 3, fourth root. It is not always going to be the fourth root. Do not assume it's always the fourth root. It just happens to be that for the examples we're doing right now. Okay. Now, your calculator will do this for you if you type it in as it is now, doing 4 over 64 as a fraction. If you type in 4 divided by 64, it won't. Be careful if you do that. Put the 4 over 64 as a fraction with parentheses around it. You got to put parentheses around what you're taking the fourth root of if it's not just a single number, because your calculator will just do the fourth root of the first thing and then divide that by whatever's behind it. Even as a fraction, if your calculator handles fractions like that, it will do the fourth root and then put that over the 64 and you'll get some really goofy crap. However, we can reduce the fraction first, and you get the fourth root of 1/16, which is the fourth root, oh, that's a horrible root. I get writing backwards, fourth root of 1 over the fourth root of 16, and the fourth root of 1 is 1, the root of 1 is 1, no matter what the root is. Fourth root of 16, we just did that, that's 2. But if you did it on your calculator, you should get 1/2. And now I can fill in the blanks. Half of 64 is 32, half of that's 16, half of that is 8, and half of that is 4 to match up my 4.
Sorry, where did the fourth power come up?
Fourth root is because I have to do R 4 times. 1, 2, 3, 4 places to get to the end. Basically, one more than the blanks we have. One more than the blanks. Yeah. Okay. Questions? Your turn. Do those two. So, gentlemen. So, you need to find R. R is, once again, the fourth root. Once again, don't always count on it being the fourth root. 0.75 divided by 12. And you get 0.5 for this one. So you're basically taking half, 6, 3, 1.5. On the next one here, same thing. R, once again, fourth root, negative 2,304 divided by negative 9, and you get 4. Which means you get negative 36. What's the next one? Negative 144. And the next one is negative 576. Thank you. Now, I want to make a note. This is one possible correct answer. Technically, there are 2 correct answers for this. Because it is possible this is an even root, this could be negative 4 as well. And that works for the other ones. Because wouldn't it also be true if this was multiplied by negative 4, got positive 36, negative 144, positive 576, negative 2304? We don't know. We don't know. In order to be perfectly clear exactly what it would be, I would have to know either the number in front of the 9 or the number after the 2304. If either one of those are negative, then they're all negatives. If either one of those is positive, then it changes sign every other time. The only reason I bring it up with this one rather than the previous one is because I do already have negatives involved. I don't know for sure which one it is. My expectation is that I would have these answers and you would use this. That would be my expectations. But if you gave me the other one, hey, you'd be just fine. Okay? You'd be just fine. Either one would work. But generally speaking, this is what I expect to have them all be the same sign, unless you know for sure. Now, if it were an even number of spaces and one was negative and one was positive, you would definitely get a negative root, a negative R, and it would tell you exactly what's going on. You would be exactly correct. Now, let's go back to what we skipped. And I'll show you how to do this using the same method that we just did. Okay? So, instead of looking for the first term and figuring out n and this whole great big problem there, this one's actually very easy to do for a couple of reasons. One, 8 is not that far from 5 in the scale of things. When you do geometric sequences, I'm not going to ask you for the 70th term on a geometric sequence. That number is going to be way, way, way too big. 3 to the 70th power is enormous. Your calculators will not deal with it. Mine won't deal with it. Most personal computers will not handle it unless they have a special program. So you're never going to get anything that far out on either end of the spectrum. So there's an easy way to do this, and it's logic rather than formula. Find R. Same way we just did, you find R. I have a sub 3, 36, then there's 4, and then 5 is 324. I have the third term and the fifth term, so I do the same thing I just got done doing to figure out what R is. So R would be the square root of 324 divided by 36 because I have one space, it's one more than the number of spaces, so I do the square root. Okay? So you divide that out. I'm trying to remember what that is. Oh, it's 3. That's right, it's 3. R is 3. Well, we don't write the little 2 you're doing. Yeah, but it is set square root. So you end up getting 3. We did this earlier. So that tells me R is 3. Now, rather than trying to plug in R into the formula, put in 3 here, put in 3 for the power, sit 6, and figure out what a sub 1 is, that's a pain in the butt. You can do it, but it's a pain in the butt. But look at this. I'm going from a sub 5, 324, there's 6, 7th, a sub 8. I want that term. This is very easy to do on your calculator. Times 3, times 3, times 3 to get 3 terms down the line. Does that make sense? So you take 324, 324 times 3, times 3, times 3, and you get 8748. Rather than use a formula that can get very nasty in a hurry, and trust me, it can get very nasty in a hurry, figure out what R is doing what we just got done doing for the geometric means, and essentially find the third term down the line. On this one here, instead of multiplying by whatever R is, divide by R twice to move backwards the other way. Figure this one out. Divide twice to figure out R going backwards the other way. Okay? Does that make sense? So I'm going to stop here.